Welcome. In this video, I'm gonna teach you an introduction to KCL and KVL, which is Kirchhoff's current law and Kirchhoff's voltage law, by giving you an example that illustrates such two concepts. Okay, so what we need to know for this video is that we need to know that the change in voltage, in other words, the voltage across the device, in case of a resistor, is going to be equal to I times R, where I is the current and R is the resistance in ohms, and current is in amps. But as you know, for resistors, we don't really write delta V. So what we do is we write V equals IR. Voltage equals current times resistance. And remember, for a resistor, if you have point A and point B, and the current goes here, goes in this direction, and let's say this is resistor R, then to measure the voltage, that means that we take two probes and we measure, and this will be B, the voltage across the device. So voltage is measured across. And when you measure across in the direction of current, this is called a voltage drop. That's why it's a difference. That's why we call it delta V. So what KCL is saying is that, let's say you have one resistor going in, current going in, another going out, and a third one going out, down. That means let's say if this is I1, this is I2, this is I3. What Kirchhoff's law is saying is that the current going in is equal to the sum of the currents going out. And you can write this in a summation as follows. So that so in other words, let's say, so I in is equal to I1 to N of let's call this one J, of IJ, current in is equal to the sum the current out, IJ out. Now let me talk a little bit about KVL. What KVL is saying is that in a closed loop, as follows. For example, you have a resistor here, battery here, another resistor here. That means in a closed loop, KVL says that if this is B0, this is B1, this is B2, it says that B0 plus B1 plus B2 is equal to 0. That means that the voltage in a closed loop, the voltage sum is equal to 0. And you can write it in summation as follows. So voltage loop of I equal 1 to j, I'm sorry, I equals 1 to n of, and this one is called a j of ij of bj is equal to 0. And also you can say that because we're doing resistors, we can say that that's equal to the sum of j equal 1 to n of ij rj is equal to 0. Of course, we need to include the source if there is a, in this case will be plus b naught is equal to 0. And this part here comes from Ohm's law. This I times R. So now let me give you an example that illustrates both concepts. So let's say we have a battery, we have a resistor, another resistor, another resistor, and then when we say this is P naught and we need to find what it is, and we're given that this one is 1k kilo ohm and then this one is 6 milliamps and then this one is 2k ohms, 2 kilo ohms. This one is 2 kilo ohms. We want to find I here. Let's say this one is B1, B2, B3. And we know the current is going this way, and this way. So this is a junction point. Okay, so Kirchhoff's current law, we can solve for I. Kirchhoff's current law says that I1 is equal to I2 plus I3. This is I1, this is I2, and I3. We're calling it I, so let's call it I3 just to make sense with Kirchhoff's law. So what's I1? I1 is 6 milliamps is equal to I2. Let's call this one let's call this one 3 milliamps. Okay, so now I2 is equal to 3 milliamps and we don't know I3. We need to find what that is. So Kirchhoff's current law says going in is going out. So what does it mean? That I3, we move this to the other side, minus 3 milliamp. So I3 is equal to 3 milliamps. So we found that this is equal to 3 milliamps. Oh, last thing we need to do is we need to find B naught. So in a closed loop, so let's take this loop here. So it says that B0 plus B1 plus B3 has to equal 0. That means that B0 minus 1 kilo ohm times 6 milliamps minus 2 kilo ohm times 3 milliamp equals 0. That means that B0 is equal to 6 plus 6, which is equal to 12 volts. So this is equal to 12 volts. This is 3 milliamps. How can we tell that we have the answer? Let's double check it. Now let's take an outer loop. But now we know. So 12 volts. Okay, let's write it in terms of variables. Okay, so B0 plus, this is B1, plus B2 has to equal 0. Let's see if that's the case. So B0 is equal to 12 volts, and then we do minus B1, which is equal to, we found here, is 6, and then 3 times 2, 6 minus 6, which is indeed 0, so this checks out. So we do have an answer. And to demonstrate this loop here, see, this is 6, this is 6, so if we do minus 6 plus 6, because they are going opposite direction, that is equal to 0, which is the case, which is Kirchhoff's voltage law, that the voltage around a loop is equal to 0. The voltage sum minus 6 plus 6 equals 0, which checks out. So we use Kirchhoff's current law to find the I3, and then to find V0, we use Kirchhoff's voltage law. Thank you very much. Don't forget to subscribe, please.